Hello everyone, welcome to this video. My name is Amir Senahari. I'm a Google Earth Engine expert. Today I'm gonna show you how to calculate precipitation data and extract precipitation information from the Google Earth Engine platform. In the most of earth science projects, when you want to have access to the climatological data, precipitation and temperature are the most important factors in this regard. So here, for example, imagine that you have no access to the in-situ measurement or ground stations to or synoptic data for the precipitation. And here, in this situation, Google Earth Engine provided a good ability to have access to the climatological data in a diverse set of products here. So let's go to the Google Earth Engine platform. So in the first step, we need to define the region of the interest. You can choose wherever in all around the world as your location. It doesn't matter which locations you are going to work, because the precipitation data I'm going to introduce you today included all around the world. For example, I want to select a part of northwestern of Iran, more precipitation rate in this region, in the Persian Plateau expected. So here, by the drawing tools available here, for example, rectangle tools, I draw a rectangle to set my region, and I want to get the precipitation data in different temporal frequencies such as daily, weekly, monthly, and annually. It's very, very important because most of the time precipitation data are available only for 3 hours, only for days, but it depends on the project which kind of temporal frequency needed. For example, it is daily, but we need it monthly, or we need it in annual scale. So here I'm going to show you how we can deal with this data and how we can convert the temporal frequency of the precipitation data and prepare multi-temporal products for the precipitation estimation. So after defining location of the interest by the map.center object, you can have focus on your region of the interest as a geometry already entitled here. And next, we need a variable, for example, GPM Global Precipitation Measurements product is available in the Earth Engine platform. And through the search places and dataset, if you go to browse data catalog, but in the browse by tags, if you write something like climate or precipitation, you can see that variety of precipitation data sets are available. For example, here we have 40 dataset products available in the Earth Engine platform so far, and you can see all of them, some of them directly measured by the satellite and some of them assimilated by the remote sensing satellites and in-situ measurement and something like that. So for example, here we have GPM data with 3 hours and monthly temporal frequency. Now I want to use GPM, or Global Precipitation Measurement version number 6, available since 2000 to 2024, and also it's a real time with a 10-kilometer spatial resolution, and you can see that the precipitation estimated from the infrared region and also calibrated precipitation with a millimeter per hour is available. So, and one advantage of GPM data is that this is a global precipitation system, because some of the precipitation data coming from remote sensing satellites such as TRMM only limited to the mid-latitude regions, but GPM covers all around the world, and also we can use precipitation data for even higher latitude region and lower latitude region, not only limited to the mid-latitudes. And that's one of the main advantage of GPM data. And in most of the projects, I'm using these products, and also I found it with a good accuracy, at least in the projects I have participated. And here So we can download this data, and also just before working with this product, it is important to know if you need some description about this data. In the description part, a small paragraph briefly describe the characteristic of data, and also for the DOI and citations, some references are available here. You can cite them in your paper, and also it's important if you use some of the NASA or ESA or any organization data, cite them in your paper. So, and now I want to call global precipitation data, or GPM, version number 6 in my code, and also it is with a 3-hour temporal frequency here. Through the search places and dataset, I call them here, and you can see that it's available, and then import it into your code. So here we have image collection, or assign image collection to the GPM variable. Then we need a filter to narrow down all of the GPM data to a specific period of time. For example, I want to select 5 years here. For example, we have two variables, time start and time end. Time start equals to, I want to get precipitation data from 2005 to 2010. And another variable is time end equals to 2010. So then after image collection, we need a filter date, and filter date including time start and time end, just like that. So here, but as GPM data is coarse resolution, you don't need to bound this data by the filter bound to a specific region, because it is not, it doesn't have frame structures such as Landsat and Sentinel, and just using filter date is enough. So in the next step, we want to have a function to convert this data from 3 hours temporal frequency to the daily format, to the weekly format, or even monthly and annual format. Because in most of the projects, maybe 3 hours data is not important, but daily, monthly, weekly, or annually helping us to get the seasonal variation information, or even the trend of changes in the precipitation data, which is very important. So now I want to show you a multi-temporal or temporal collection function that is already developed by the Google Earth Engine developers, and here I'm gonna show I'm gonna share this function with you, which is very applicable to convert the daily or high temporal resolution data to the longer periods, such as weekly, monthly, and annually. Here we need a function. Its name is temporal collection. You can choose any other names that you prefer. Temporal collection. Most of the time, people call this as a temporal composite. It doesn't matter which kind of name you are using for your function. The only thing is matter is how to write this function and how to use this function in the real projects and get accurate results. So in the temporal collection, we have variety of arguments. The first is the collection of the data we want to use, and the collection will be GPM data. And the next one is the start time, which will be equal to the time start. And the next is the count, the number of images we expect to have after temporal collection. And the interval, the distance between two times, how long difference between one image and two, between the first and the second image. For example, it is weekly. If we want to have weekly with 1 week, interval is 1. If we need images with every 2 weeks, average, it means the interval will be equals to 2. And also I will show you in the next step how it's working. And finally, the last argument is units. The unit is very important because we can set daily, monthly, and also the annually by the unit. So in the first step, we need the list based on the number of images expected to have at the end. So here I make a sequence list Earth engine dot list dot sequence. By the pressing control space together, you can see the arguments. Only a start and end is important. The start, set the start to 0, and also instead of the end, Earth engine dot number. Here you can see that Earth engine dot number dot count. The count will be the number that we put here, and then as the here the sequence, the list of sequences started from 0, and to the count we need to subtract count from 1. So here, and then we need to have a start with the date format, because instead of a start we will enter a string number, a string structure for 2005, which is the start year, and in order to convert to 2005 to the date format, we need to use this function. Here we will have origin date equals to Earth engine dot date for the time start. By Earth engine dot date, the string imported converting to the date format actually. So now we need to return the sequence of the list as an image collection. Here, return the function in the first step, returning an image collection. So here we need to have a list of sequence as an image collection format, but it is now empty. And for each row in this sequence of list, we need to make a function and set the start time and end time based on the interval and unit. So here we add this list of sequence into a function, just like that, and each row from this list consider it as an I, and then in the new function created here, we want to set the start date and end date. The start date equals to from origin date already defined dot advance. So here the delta equals to the interval Earth engine dot number interval, and interval must be applied on each row, and unit will be same. At the end we can identify what kind of unit we will have. In the next step I will show you. So the next, we will have the next variable here, the next variable is end date equals to, again, origin date dot advance, same as before, with a little change, Earth engine interval dot multiply here, Earth engine dot number, consider it I as a number, plus 1 dot add 1 based on the unit that we will identify. So finally, they could return a collection. For example, GPM is an input collection here for a specific period in each date. That filter date, the period already defined by the start date and end date. And as we are working with the precipitation data, it's important to get some of the precipitation for the daily, weekly, monthly, or even annually. We don't get the average of precipitation for the temporal collection or temporal composite. The sum of the precipitation should be considered when you are working with the precipitation data. It's very, very important things that you should consider in your projects. So in the temporal aggregation for the precipitation, it is matter to consider the sum of the precipitation. So then we need to do the time series analysis, we need to have access to the system time start and system time end. by the set, we can define new properties for the new image collection that is creating under temporal collection function. So that set, we will have system time start, and system time start equals to the start date dot millisecond. As Google Earth Engine read the dates with the millisecond in the properties and time series analysis, it is important to convert the date format to millisecond. So then we need to have system time end to system time end equals to end date dot millisecond. So remove the spaces here, and then we need to apply this function on GPM data to get the daily precipitation measurements actually. So here we need a new variable which is daily. The function already created is temporal collection, and here we have 5 arguments, and instead of each argument we need to replace each argument with another variable or another factor or criteria. Instead of the image collection, we will have the GPM. As we want to have calibrated precipitation in the GPM dataset, you should select the precipitation calibrated based on millimeter per hour here in your code. And before it, then I select calibrated precipitation for the input, and instead of a start we will have time start. Instead of the count is important. For example, here we want to have 5 years daily data. If you go to the calculator, if you consider each year as a 365 days, and when you multiply this to 5, for example, for the 5 years, we expect to have more than 1,800 images. So 1,825 images expected here with 1 day interval instead of replace the interval with number 1, and the unit should be days here. Then print the results, the daily precipitation. Now we want to see that, yeah, here you can see that 1,825 elements returned here, and also for all of the images we should have 1 band. As you can see, all of them including 1 band. Yes, there is, showing that we did correctly, and also there is no syntax problem in our code. So then, for example, imagine that we want to convert it to the monthly format, but before it we can show the daily variation of the precipitation with the for example flowchart, with the chart actually. User interface dot chart dot image dot series. We want to get average of precipitation in the region of the interest with the daily format from 2005 to 2010. Instead of the image collection, replace image collection with daily, and the region of the interest is geometry. Reducer, here we have a spatial aggregation. You can have different types of the spatial aggregation: minimum of a region of interest, maximum of region of interest, sum of the region of the interest. It depends on your purpose, but normally we use the average of region of the interest. We want to get average of daily precipitation in the regions selected. So Earth Engine dot reduce dot mean. Instead of a scale, we will have 10,000 meter because we have 11 kilometer, or even we can enter 11,000 meters. Instead of X property, we will have system time start, and then run the code. Code is running, chart is generating, And after a few seconds, it depends on the volume of processing, you can see the rate of precipitation changes through a plot since 2005 to 2010 by daily format estimated from GPM data. And also, as precipitation has discrete value, it would be better to use column chart to show the precipitation changes. Here by set chart you can identify that, or also you can set a specific kind of chart for your plot. For example, here I want to show the precipitation by the column chart like this. And as code is generating, we can continue programming for the monthly and also annually to get the to compare the results. Now it's calculated, and now you can see that the precipitation data is available by the millimeter per day. For example, you can see that there are some extremes for some dates, and also sometimes during the summer we have low precipitation rate, and also in the spring and also in the winter there is a high precipitation rate. And you can get the precipitation values through the download CSV as an Excel format and get it for the further processing in the Excel or Python programming language. So we can repeat this process steps for the monthly and also the annually. For example, I want to get the monthly data here. So here, make a new variable. Just make more space here, and the variable is monthly equals to temporal collection. Keep the GPM, keep the time start, but the number of images should be changed. Each year we have 12 months. For 5 years we will have 60 months. Here you can see that 61 months. Instead of the days we will have months, and by the same print function and chart function we can see the so here instead of the daily we can see the monthly variation of the precipitation by the column chart in our region. And also by set options you can set some kind of characteristic for the plot. For example, you can have a new name, you can change the color or doing something like that. For example, the title here could be, for example, monthly precipitation. And also remember that precipitation including rainfall and snowfall together. When we say this data is precipitation, it meaning that it's including it is including the rainfall and snowfall together. And then, for example, if you want to change the color of plot, for example, we throw the series, we make a new argument. The first plot entitled as 0 equals to the color will be, for example, red. And then run the code, and the code is running, charts are generating. You can this is the daily with the column chart. You can see that column chart provided better visualization for the precipitation data. And with the monthly we can do the same for the annually. Keep the GPM time start, and here you can see that the monthly precipitation changes in this region. And then we will have GPM time start 5 years, each 5 images with 1 year interval. For example, if you want to have 2 months interval instead of 1, you should have 2. So the annually, a new variable replaced by the monthly replaced by annually here. And then we have annual precipitation with another color, for example, orange. This is daily. This is monthly precipitation. And then we have the annual precipitation data. Waiting for the chart to be generated. If you had any question regarding to the programming steps, or if you faced with any problem during the programming, specifically when you are working with the temporal collection, you can put the comments in my YouTube page, and also ask me about your problems, and also or share your code through the comments, and I will check it out and try to solve your problem. But I can only have focus to the problems you share regarding the code. I have already I'm teaching you in this video actually. So sometimes generating chart is a little time consuming process. It depends on the volume of the data. It depends on the kind of programming steps. I tried to write the code as simplest as I can to be very light and also be very fast. Run it again. Yeah, and now you can see that the precipitation data estimated for this region with the annual rate, and you can see its variation from one year to another. And also there is another important things in precipitation or climatological data analysis. Maybe sometimes you need to have access to the raster formats, not only the Excel format with the daily, monthly, or annual trends. And sometimes we want to get or have the raster data for the further modeling in the ArcGIS or any other kind of modeling. And also it's very important to know that how we can get export, for example, from annual precipitation raster and use it in another modeling techniques. For example, imagine that we want to download the annual precipitation data. It's very, very easy. Just using the user interface through the export.image to drive, you can export any image collection you want. So there are different arguments that should be considered for the exporting raster layers here. For example, one of them is image. The image you want to extract is for example, annual data. But annual data is a image collection. In order to download it, first we need to convert it from image collection to an image stack, to an image including all the dates together. So annually, to do this, using two bands to stack all of the bands or all of the dates into a single layer or into a single grid structure, and then clip it based on the region of the interest. It is geometry here. By the description, we need to set a name for the output. For example, here I named it as a precipitation with the annual temporal frequency. And another thing is about the scale. It is important to set the original spatial resolution for the scale, and region of the interest should be introduced as geometry or table or whatever you have. And max pixel means the maximum of pixels that each image can include. Each image includes equals to 1e13 max pixels, and CRS or coordinate system equals to for WGS for the WGS 84. You should write its code like EPSG and 4326. That's the code for WGS 84 or the coordinate system. If you want to have this output in a single folder in your Google Drive, you can type the name of the folder you want. And also if there is no such folder in the Google Drive, it doesn't matter. Google automatically make a folder such as test in your Google Drive and will store or save the final result in there, and then you can pick it up from there. Yeah, these are important arguments should be considered for exporting raster layers or an image collection into the Google Earth Engine platform. And to avoid some of the problems during the processing or saving, would be better to convert the variables, convert the type of variables to the float by .float function. Run the code again, and then in the task, finally, you will have the precipitation annually available here. Click on run. Don't change anything here. Just click on the run again. And now we are waiting to have the annual precipitation. Once the process of saving in Google Drive is done, the color of this panel turned to blue, such as previous exports that I have done. And now we should wait to see how long it takes for the storing of this data in the Google Drive. Yeah, and also if there is any problem regarding to the saving or storing data into the Google Drive, the panel color turn to the red, and then you will have a message here. You can contact me and I will show you how to solve the problem. But I think if you care all of these steps, as I told you, it is unexpected to have such kind of error during the saving your result into the Google Drive. So thank you for watching me in this video, and I hope you can work with this code in your projects. If you had any questions, feel free to contact and reach me out. Thank you for your attention.